It's 10 o'clock at night. You're loading the dishwasher and you hear it. A tiny sickening snap. You look down, and the little plastic clip that holds up the corner of the top rack has finally given up. It's shattered. Now the whole rack slumps to one side, completely useless. So you do what any of us would do. You pull out your phone, you type in your dishwasher model number followed by top rack clip. And there it is. A tiny piece of injection molded plastic, no bigger than your thumbnail. And the price? $37, plus $8 for shipping, for a piece of plastic that probably cost the manufacturer a tenth of a cent to make. And you won't even get it for a week. So for the next 7 days, you're either hand-washing dishes or playing a high-stakes game of Jenga with your plates. It's infuriating. It's the perfect example of a tiny problem creating a massive annoyance. All because you're at the mercy of a supply chain and a company's outrageous markup on spare parts. But what if you weren't? What if, instead of going online to buy it, you just made it? What if you could walk over to a machine on your desk, download a file for free, and in the time it takes to watch a movie, have a brand new, potentially even stronger replacement part in your hand? For a cost of about 3 cents. This isn't science fiction. This is the reality of owning a 3D printer in your home today. And that little dishwasher clip? That is the tiny, unassuming key that unlocks a completely new way of looking at the world around you. It's the first step in a journey from being a passive consumer to an active creator. Over the next few minutes, I'm going to show you 10 mind-blowing categories of things you can create with a 3D printer at home. And I promise you, we are going far beyond the little plastic figurines and trinkets you might be picturing. We are talking about items that will genuinely save you hundreds, if not thousands of dollars. We're talking about custom solutions that will organize your life in ways you couldn't even buy. We're talking about turning your ideas into physical objects and solving those frustrating little problems that make daily life just a little bit worse. Now, I know what some of you might be thinking. A 3D printer? Isn't that incredibly expensive and complicated? Don't I need to be some kind of engineering genius or a computer-aided design expert? 10 years ago, you would have been absolutely right. But today, you would be absolutely wrong. The prices have plummeted. You can get a fantastic, highly capable machine for less than the cost of a new video game console. The software has become so user-friendly that if you can use a web browser, you can prepare a file for printing. And as for being a design expert, you don't have to be, because a global community of millions of creators, engineers, and hobbyists has already designed virtually anything you can think of, and they've uploaded the files online for you to use for free. Think of it like a search engine for physical objects. If you can think of it, chances are someone has already designed it, perfected it, and is sharing it with the world. So let's start with the very foundation of this superpower, the category that dishwasher clip belongs to. The first mind-blowing thing you can create with a 3D printer is your own personal, infinite, on-demand hardware store. This is what I call the never buy it again repair kit. Let's go back to that broken clip. The process is so simple it feels like cheating. You go to a website like Thingiverse or Printables or My Mini Factory. You type Whirlpool dishwasher rack clip into the search bar, and instantly you see dozens of results. People all over the world had the exact same problem you did. They got frustrated, they fired up their design software, and they solved it. You find the one that matches yours, you click download, you open it in a free program called a slicer, click a button with a preset profile like standard quality, and send it to your printer. Then you walk away. A couple of hours later, you come back to a perfectly formed brand new clip waiting for you on the printer bed. You pop it off, walk over to the dishwasher, and with a satisfying click, your problem is solved. The rack is level. The crisis is averted. And the feeling of self-reliance you get from that moment, it's addicting. You just defeated the system. You beat planned obsolescence. You fixed something for pennies that a corporation wanted to charge you nearly $50 for. And this is where the obsession begins. Because once you fix that one thing, you start seeing opportunities everywhere. You start walking through your house with new eyes. That battery cover for the old TV remote that's been held on with duct tape for 5 years? You can print a new one. The plastic knob that snapped off your washing machine, forcing you to turn the dial with a pair of pliers? You can print a stronger one. The little rubber foot that fell off your favorite cutting board, making it wobble every time you try to chop an onion? You can print a whole new set out of a flexible, grippy material. Let's take a tour. In the office, you're tired of the mess of cables behind your monitor. Instead of buying some generic cable clips that don't quite fit, you print custom ones that are perfectly sized for your exact desk thickness and your exact number of cables. You print a custom bracket to mount your power strip perfectly hidden on the underside of your desk. You print a little angled stand for your phone that holds it at the perfect viewing angle for your video calls. In the garage, the handle on your favorite shovel cracks. You print a new, more ergonomic one. You need a specific jig to make a perfect 90-degree cut with your circular saw. You download a design and print one. The plastic housing on your leaf blower cracks after a drop? You print a replacement part. Each of these is a small victory. A $10, $20, or $50 bill that stays in your wallet. And here's where it gets even better. You're not just replacing the broken part. In many cases, you're upgrading it. The reason a part breaks is often because of a fundamental design flaw. It was made as cheaply as possible, with the thinnest possible plastic, designed to fail just outside the warranty period. But the community of makers online? They're not bound by that. They identify that weak point and they reinforce it. They add a little more thickness, a supporting brace, a stronger curve. So when you print the community-designed replacement for your shattered fridge shelf bracket, a part notorious for failing and costing a fortune to replace, you're often printing a version that is fundamentally superior to the original. It will never break in the same way again. You have the power to not only repair but to improve. You can even choose your material. The original part might have been made from a brittle, cheap plastic, but you can choose to print its replacement in something called P2G, a material that's far tougher and more heat-resistant. The same family of plastic used to make water bottles. Or you could print it in ABS, the same stuff Lego bricks are made of, known for its incredible durability. You're not just a consumer anymore. You're the production manager, and you can decide exactly how your part is made and what it's made of. This single category, the ability to repair and upgrade anything made of plastic in your life, is enough to justify the entire hobby. It's a quiet rebellion against throwaway culture. It transforms you from someone who has to buy a solution to someone who can create one. So, fixing every broken plastic piece in your home is a legitimate game changer. It's like having a magic, infinitely stocked hardware store on your desk that's open 24/7. But what if we moved beyond just fixing things made by others? What if we started creating entirely new things from scratch that you can't even buy in a store? Things designed to solve a problem that is completely unique to you and your home? What if we could tackle the most cluttered, disorganized spaces in your house and create perfect, custom-fit harmony? That's exactly what we're diving into next. And trust me, your kitchen drawers, your workshop, and your closets will never be the same. We've all been there. That one drawer in the kitchen, the one you're almost afraid to open. It's a chaotic graveyard of forgotten objects. A tangle of rubber bands, paper clips, and twist ties. A lone battery rolling around, its charge a complete mystery. 3 dried-up pens, a single Allen wrench from a piece of IKEA furniture you assembled 5 years ago, and that tiny screwdriver for your glasses that you can never find when you actually need it. We buy those flimsy, generic plastic organizers from the store, hoping for salvation. But they never fit. There's always that awkward gap on the side where things fall through, or the compartments are too big for your paper clips and too small for your measuring spoons. It's a compromise. It's a band-aid on a problem that feels fundamentally unsolvable. But what if I told you the solution isn't about buying a better box? It's about creating a perfect system. A system designed by you for you with millimeter precision. This is where 3D printing doesn't just change the game. It throws the old rulebook out the window. You are no longer a consumer of one-size-fits-all solutions. You are the architect of your own order. You have the power to measure any space in your home, that drawer, that shelf, that weirdly shaped nook in your closet, and conjure a perfectly tailored organizational masterpiece into existence. Let's go back to that kitchen drawer. Imagine you take its exact measurements: 14¼ inches wide, 20½ inches deep, 3 inches high. Now, instead of searching online for something that's close enough, you open a piece of free software. Or even better, you go to a website like Printables or Thingiverse and find a parametric drawer organizer. Parametric is just a fancy word for customizable. You don't design it from scratch. You just type your numbers 14.25, 20.53 into a few boxes. You decide you want a long slot for your pens, a square section for sticky notes, and a few small curved dishes for clips and pins. You click Generate. And like magic, a perfect 3D model of your dream organizer appears on the screen, ready to print. A few hours later, you pull a series of interlocking, custom-fit trays off your 3D printer. They feel solid, substantial. You slide them into the drawer, and they click into place with a satisfying finality. There are no gaps, no wasted space. Every single item from that chaotic mess now has a home. The batteries are lined up in neat little rows. The pens are separated from the pencils. The Allen wrenches are organized by size. You slide the drawer closed and open it again, just to experience the sheer zen-like calm of seeing perfect order where chaos once reigned. This isn't just cleaning up. This is fundamentally upgrading your home. And this principle extends far beyond the kitchen. Let's walk into the garage or the workshop, a place where good organization can mean the difference between a quick 5-minute fix and a frustrating hour-long search for the right tool. Look at that pegboard. It's a great idea in theory, but those generic metal hooks are terrible. Tools fall off, they slide around, and you can never quite get the spacing right. Now picture this. You print a custom holder for your specific set of screwdrivers, with each slot perfectly molded to the handle, holding it securely at the perfect angle. You print a holder for your power tool batteries, with slots for charged and uncharged, so you always grab a fresh one. You print a complete socket organizer, not just with holes, but with the sizes 10mm, 12mm, 14mm, embossed right into the plastic. No more squinting to read the tiny engravings on the socket itself. You've just created a system that's faster, more efficient, and infinitely more satisfying to use. You're not just storing your tools, you're creating a workflow. The modern world has created its own unique brand of clutter, and it's usually a tangled mess of wires behind your desk. The power strip is a rat's nest of black cables. Your phone charger, your laptop charger, your monitor cable, it's a digital jungle. With a 3D printer, you become the master of that jungle. You can print small, elegant clips that stick to the underside of your desk, routing each cable invisibly along a designated path. You can design and print a custom docking station for your desk, one that holds your specific phone, your specific smartwatch, and your specific wireless earbuds, all in one sleek, unified hub. No more fumbling for 3 different cables. You've just created a single elegant piece of functional art that declutters your space and your mind. The possibilities are truly endless, and they start to pop up everywhere you look. That jumble of remote controls on the coffee table? You can print a caddy that holds the 3 you actually use perfectly. That collection of video game controllers and headsets? A custom printed stand can turn them from a messy pile into a display piece. The spice jars in your pantry that are all different sizes? You can print a modular tiered rack that fits your exact shelf depth and your specific jars. You can print a holder for your coffee pods that slots perfectly into that weird, narrow space next to the espresso machine. You can even print custom dividers for your sock drawer. Sounds obsessive, but once you experience that level of perfect organization, you can't go back. And here's the most empowering part. You don't have to be a professional 3D designer to do any of this. The online communities have already created and shared hundreds of thousands of solutions. For almost any organizational problem you can think of, someone has likely already designed a brilliant free solution that you can download and print in minutes. And with the rise of those simple parametric models, customization is becoming as easy as filling out a form. You can choose your material too. For most things, a standard, easy-to-print material like PLA is perfect. It's strong, comes in a rainbow of colors, and it's even derived from plant-based sources. But for those heavy-duty workshop tool holders, you might use something tougher, like PETG, the same type of plastic used to make water bottles. It's more durable and heat-resistant. The ability to choose the right material for the job is another layer of control you simply don't get with off-the-shelf products. Ultimately, this is about more than just tidying up. It's about reducing the tiny points of friction in your daily life. It's the small, quiet victory of opening a drawer and finding exactly what you need, instantly. It's the sense of calm that comes from a workspace where every tool is in its place. It's the pride of looking at a problem, designing a solution, and creating a physical object that makes your life better. You're not just printing plastic, you're printing peace of mind. You are creating a home that works for you, not against you. By conquering the clutter and chaos inside our homes, we've built a foundation of order and control. We've used this incredible technology to solve everyday problems with custom, perfect-fit solutions. But 3D printing isn't just about practical fixes and logical organization. It's also a gateway to unleashing pure creativity. So what happens when we take this power, this ability to turn a digital file into a physical reality, and apply it to our passions, our hobbies, and the things that bring us joy? What if we could stop just organizing the tools for our hobbies and start printing the hobbies themselves? That's where we're going next, and it's where the real magic begins. For centuries, we've built worlds in our minds. We've read books about distant galaxies and epic fantasy realms. We've played video games that let us explore digital landscapes. But these worlds have always been trapped, either behind our eyes or behind a screen. The 3D printer changes that. It becomes a portal, a gateway to bring the imaginary into the real. And there's no better example of this than in the universe of tabletop gaming. If you've ever played a game like Dungeons & Dragons, Warhammer, or any of the thousands of tabletop war games, you know the feeling. You have this incredible character in your head. A stoic dwarven warrior with a notched axe and a braided beard, or a stealthy elven ranger with a longbow slung over her shoulder. You want to see that character on the table, to move them across the map, to feel their presence in the game. So, you go online or to a hobby store and you start searching. And you find something that's close. It's a dwarf, sure. But his axe is wrong. The armor isn't quite right. It's someone else's version of your hero. And it costs $15. For one. Now imagine you're the one running the game, the dungeon master. You've designed an epic encounter in a goblin-infested cave. You need goblins. Lots of them. 10, 20, 30. At $5 to $10 a pop, you're suddenly looking at a couple $100 just for the cannon fodder. And then you need the cave itself. The stalagmites, the crumbling walls, the treasure chests. It's an incredibly creative and rewarding hobby, but it's a hobby that has historically been limited by the size of your wallet. Your imagination could be infinite, but your budget wasn't. This is where the 3D printer doesn't just change the game. It revolutionizes the entire universe. Suddenly, you're not a consumer of someone else's fantasy anymore. You are the creator. That dwarven warrior in your head? You can find a digital file for him online, created by a talented 3D artist. But you don't have to stop there. You can customize him. Using simple free software, you can digitally swap his axe for a hammer. You can add a shield with your own custom emblem on it. You can pose him in a heroic stance, ready for battle. And then you hit print. And a few hours later, emerging from a pool of liquid resin or built layer by layer on a print bed, is your character. Perfect. Exactly as you imagined him. The total material cost? Maybe 50 cents. That one moment when you hold a physical object that began as a pure idea in your mind is a paradigm shift. The barrier between imagination and reality has been completely shattered, and it goes so much deeper than just one character. Remember that army of 30 goblins? You can print them all for the cost of a single store-bought miniature. You can print them in different poses with different weapons: goblin archers, goblin swordsmen, a big, ugly goblin shaman. You are no longer limited to the 3 generic poses the big company decided to manufacture. Your goblin horde is now truly your own, unique and teeming with life. But why stop at the creatures? Let's build the world they live in. That cave? You can download and print modular cavern tiles. Pieces that snap together like Legos, allowing you to build any cave system you can imagine. You can print the stalagmites, the underground rivers, the rickety rope bridges. You can print treasure chests that actually open and close, filled with tiny piles of gold and miniature magic swords. You can build the entire tavern where the adventure begins, complete with tiny tables, chairs, and beer steins. You can print the towering fortress of the evil lich, with crenellated walls, imposing gates, and spooky gargoyles. You're not just placing characters on a flat, hand-drawn map anymore. You are creating a 3-dimensional, tactile, immersive world for your friends to explore. The storytelling potential is astronomical. When your players can actually see and touch the crumbling altar or the trapped corridor, their level of engagement goes through the roof. And the level of detail modern printers can achieve is simply breathtaking. We're talking about resin printers that can capture the individual chain links on a suit of mail, the wood grain on a shield, or the menacing snarl on a dragon's face. The quality of home printing now rivals, and in many cases surpasses, the quality of mass-produced, injection-molded miniatures that you'd pay a premium for. You can then take these prints and enter another incredibly rewarding hobby: miniature painting. Bringing these creations to life with your own color schemes, your own artistic flair, adds another layer of personalization and pride. Now you might be thinking, this sounds amazing, but I'm not a 3D artist. I can't sculpt a dragon on a computer. And that's the most beautiful part. You don't have to. There are massive online communities and marketplaces like My Mini Factory, Thingiverse, and Cults 3D that are filled with literally millions of models. Some are free, shared by hobbyists who just want to see their creations come to life on tables around the world. Others are sold by incredibly talented independent artists who make a living designing the most spectacular creatures and characters you can imagine. You can support these artists directly, often for just a few dollars a model, And in return, you get a file you can print as many times as you want. It's a complete democratization of creativity. Instead of a few massive companies dictating what your fantasy world looks like, it's now a global community of artists and makers, all sharing and building worlds together. And this isn't limited to just fantasy. Are you a history buff? Imagine printing and painting entire, historically accurate legions of Roman soldiers to refight the Battle of Cannae on your dining room table. Or meticulously detailed tanks for a World War II skirmish game. Into science fiction? You can print entire fleets of unique starships, from tiny fighters to massive capital ships, each one customized to your exact specifications. You can even design and print custom pieces for classic board games you already own. Don't like the little wooden houses in your favorite game? Print detailed, custom-designed cottages. Want a more thematic chess set? Print one where the pieces are characters from your favorite movie or book series. This is what it means to print your hobby. It's about transforming a passive experience of consumption into an active, endless act of creation. It's about saving a remarkable amount of money, yes, but the real value is so much greater. It's the freedom to create anything. The freedom to make your game, your story, your world exactly that, yours. We've brought our imaginations to life on the tabletop, creating static, beautiful worlds frozen in a single moment. But what if we could take that same principle of creation and give it motion? What if we could print things that don't just sit on a table but soar through the sky? That very question, the dream of flight, is no longer the exclusive domain of massive corporations and aerospace engineers. It's happening right now in garages, basements, and workshops all over the country. The answer is number 4. Fully functional, custom-designed drones and remote-controlled aircraft. Now hold on. I know what you're thinking. You can go to any big box store and buy a drone. You take it out of the box, charge it, and fly it. That's being a consumer. What we're talking about is something entirely different. This is about becoming a creator, an aviator, a designer. It's the difference between buying a painting and learning to paint the masterpiece yourself. When you 3D print your own drone, you're not just assembling a kit. You're fabricating the very skeleton of a flying machine tailored precisely to your vision. Imagine this. You start with a simple file on your computer, a quadcopter frame, maybe sleek and aggressive, designed for speed. Or perhaps it's a larger, more stable platform, built to carry a high-quality camera. You choose your material. Not just basic plastic, but maybe a carbon fiber-infused nylon. Something incredibly light yet ridiculously strong. You hit print, and for the next several hours, your machine works tirelessly, layer by infinitesimal layer, extruding molten plastic into a tangible, physical object that, until now, only existed as data. This printed frame is your canvas. It's the chassis of your aerial vehicle. Now comes the magic of integration. You're not printing the electronics, of course. You're sourcing the guts. The 4 brushless motors that will scream to life, the electronic speed controllers that act as their neural pathways, the flight controller which is the brain of the entire operation, and the tiny receiver that will listen for your commands from the ground. This is where the real learning begins. You're not just snapping pieces together. You're learning about thrust-to-weight ratios. You're understanding how the placement of a battery affects the center of gravity. You're soldering connections, routing wires, and for the first time truly understanding how these incredible machines actually work. You're connecting the flight controller to your computer, diving into open-source software like Betaflight, and tuning the parameters, telling the drone exactly how you want it to behave. Do you want it to be a gentle, cinematic flyer, smooth as silk? Or do you want it to be a hair-trigger racing machine, capable of flipping and rolling on a dime? You decide. You are the architect of its personality. And then comes the moment of truth. You take it out to an open field. You set it down, step back, and take a deep breath. Your heart is probably pounding a little. This isn't a toy you bought. It's a machine you built. You push the throttle forward on your controller. The props spin up from a whisper to a high-pitched whine. And then it lifts. It hovers, perfectly stable, a foot off the ground. It's responding to your every input. You push it forward and it surges through the air, a physical manifestation of your skill, your knowledge, and your creativity. The feeling is absolutely electric. There is nothing else like it. But this is just the beginning of the rabbit hole. Because once you've built one, your mind starts racing with possibilities. The standard frame is great, but what if you need a custom mount for your specific camera, angled at precisely 27 degrees for that perfect cinematic shot? You don't need to buy one. You go home, spend 30 minutes in some free design software and print it. What if you want to get into first-person view, or FPV racing? You can design and print frames that are lighter, tougher, and more aerodynamic than anything you can buy off the shelf. You can even print custom protective parts, like motor guards or camera canopies, in vibrant colors that make your drone uniquely yours. You become part of a global community of builders, sharing designs, troubleshooting problems, and constantly pushing the limits of what's possible. And we're not just talking about quadcopters. This technology has completely revolutionized the world of remote-controlled airplanes. There are designers out there creating breathtakingly complex models of warbirds, stunt planes, and futuristic jets, all designed to be 3D printed in sections. You print the fuselage in multiple parts, the wings, the tail stabilizers. The designs are brilliant, often incorporating internal truss structures that make them incredibly strong yet feather-light. You spend your evenings assembling these pieces like a high-tech puzzle, installing the motor, the servos, the control linkages. The result? You can have a massive, beautiful aircraft with a 6-foot wingspan that you literally manufactured in your own home. You're no longer limited by what's available in a hobby shop. If you can dream it and you have the patience to design and print it, you can fly it. We're seeing people print everything from faithful replicas of a P-51 Mustang to experimental flying wings that look like something straight out of science fiction. Each one is a testament to the power of distributed manufacturing. This isn't just about making toys. It's a hands-on education in engineering, aerodynamics, electronics, and software. It's about problem solving. When a crash happens, and it will, you don't throw the whole thing away. You go home, identify the broken part, and simply print a new one. You're back in the air in a matter of hours, not weeks. You learn to iterate to improve. Maybe you add a bit more thickness to that arm that broke. Maybe you redesign the landing gear to be more robust. You are in a constant cycle of creation, testing, and refinement. So we've conquered the world of static miniatures, and now we've taken to the skies, creating complex machines that defy gravity. We've turned our desktops into personal aircraft factories. We've empowered ourselves to not just use technology, but to build it, to understand it, and to customize it to our will. We've taken control of the air. But the true power of this technology might not be in creating things for our entertainment or for exploring the world from above. The most profound impact might be found in how it can change a life right here on the ground. What if we could use a 3D printer not just to build a hobby, but to build a helping hand? This isn't a hypothetical. It's a reality, happening in thousands of homes, garages, and makerspaces across the country right now. We're talking about 3D printed prosthetics and assistive devices. And this right here is one of the most powerful examples of how a desktop machine can fundamentally alter the course of someone's life. First, you have to understand the problem. A traditional, professionally fitted prosthetic hand or arm can be astonishingly expensive. We're not talking about a few $100s. We're talking about costs that can range from $5,000 to $50,000, or even more for advanced myoelectric models. Now imagine you're the parent of a growing child. That $50,000 device they need today will be too small in a year or two. The financial burden is immense, often insurmountable. For millions of people around the world, especially in developing nations, a functional prosthetic is simply an impossible dream. It's a technology locked away behind a massive financial wall. Until now. Until a community of makers, engineers, designers, and everyday people with 3D printers in their basements decided to tear that wall down. This revolution has a name, Nable. It's a global open-source community that designs and shares 3D printable prosthetic hands and arms, completely free of charge. The designs are online for anyone to download, modify, and print. So what are we actually printing? Forget the complex, Hollywood-style bionic arms with whirring motors and sensors. The most common Enable designs are brilliantly simple and purely mechanical. Imagine a hand, printed in lightweight, durable plastic. It has articulated fingers connected by a series of tensioning cords, like fishing line or elastic strings, that run up the back of the hand to a brace on the wrist. When the user bends their wrist, it pulls on these cords, causing the fingers to curl inward into a grip. Straighten the wrist, and the fingers relax open. It's an elegant, clever design that uses the body's own motion to create function. And the cost? Instead of $50,000, the raw materials to print one of these hands, a spool of plastic filament and a few dollars in hardware like screws and cords, can be as little as $50. Sometimes even less. $50. That's not a typo. It's a paradigm shift. It means a child can have a new hand printed for them every single year as they grow, and the total cost would still be a tiny fraction of a single traditional device. But the numbers, as staggering as they are, don't tell the real story. The real story is about a 7-year-old girl who was born without fingers on her left hand. A girl who learned to do everything one-handed, but always felt a little different. She couldn't properly hold the handlebars on her bike. She struggled to carry her lunch tray at school. Simple things we take for granted were daily challenges. Her parents looked into traditional options, but the cost was just too far out of reach. Then they found a volunteer in the Enable community, a retired engineer just a few towns over who had a 3D printer running in his workshop. He downloaded the files, took her measurements remotely, and asked her a simple question. What are your favorite colors? A few days later, a package arrived. Inside was a hand, not a clinical skin-colored device trying to hide, but a vibrant, sparkling purple and pink hand. Her colors. She put it on, and with a little practice, she bent her wrist. For the very first time in her life, she watched as 5 fingers curled inward. She picked up a block, then a tennis ball. She held a water bottle with 2 hands. The volunteer had even printed a custom attachment that let her grip her bicycle's handlebars securely. That afternoon, she rode her bike around the block, grinning, her purple and pink hand holding on tight. At school, she wasn't the girl with one hand anymore. She was the girl with the awesome robot arm. The other kids didn't stare with pity. They stared with awe. They wanted to know how it worked. It wasn't a symbol of something missing. It became a symbol of her strength, her uniqueness, a superpower. This is the magic of at-home manufacturing. Customization. A boy who loves superheroes doesn't have to settle for a standard prosthetic. He can get an Iron Man-themed arm, printed in brilliant red and gold. A girl who adores Frozen can have an icy blue and silver hand, fit for a queen. It completely reframes the conversation around limb difference, transforming a medical device into a form of personal expression, of pride. And this revolution in personalized assistance goes far beyond just prosthetic hands. The same principle is being applied to create an entire universe of assistive devices for people with a huge range of challenges. Think about an elderly person with severe arthritis, whose hands are so pained and stiff that holding a fork or a pen is a daily struggle. A 10-minute print can create a wide ergonomic grip that slides over their existing silverware, giving them back the independence and dignity of feeding themselves. That's not a small thing, that's everything. Someone with limited hand strength might struggle to turn a key in a lock. You can print a custom, high-leverage key turner that makes the task effortless. For people with visual impairments, makers are printing tactile maps, braille learning blocks, and custom-fit guards for household appliances. For someone recovering from a stroke, you can print specialized tools to help with physical therapy, like custom-sized grips for weights or zipper pulls for their jackets. Each of these items represents a small specific problem that would likely never be addressed by a mass-market product. There's just no profit in making a custom pen holder for one specific person's hand. But with a 3D printer, profit is irrelevant. The only thing that matters is the solution. It allows for ultra-niche, hyper-personalized problem-solving at a scale we've never seen before. It's a shift from a one-size-fits-all world to a one-size-fits-one world. What we're witnessing is the complete democratization of assistive technology. It's taking the power out of the hands of giant medical corporations and putting it directly into the hands of the community, the family, the individual. It's about seeing a problem, not as a barrier, but as a design challenge. It's proof that sometimes the most profound innovations aren't about creating something impossibly complex, but about making a simple, elegant solution accessible to absolutely everyone. We've used this machine to print a drone to see the world from a new perspective, and now we've used it to fundamentally change how someone can interact with that world. We've printed a helping hand. We've printed independence. We've printed dignity. So we've rebuilt a human's capability. We've restored function on the most personal level imaginable. What if we could apply that same power of custom creation and repair to the world immediately around us? To the very homes we live in? The answer is a resounding, world-changing yes. Because the same principle of identifying a need, designing a solution, and creating a physical object from thin air doesn't just apply to the human body. It applies to the single most frustrating, money-wasting, and environmentally damaging aspect of modern life: planned obsolescence. Think about it. That little plastic clip on the top rack of your dishwasher. It costs the manufacturer maybe 3 cents to produce. But one day, after years of heat and detergent, it becomes brittle and snaps. You go online to find a replacement. But they don't sell the clip. They sell the entire upper rack assembly for $75. Or worse, the model is discontinued and they don't sell the part at all. Your only option, according to them, is to buy a brand new $500 dishwasher. All for a 3-cent piece of plastic. This isn't an accident. It's a business model. It's the reason the battery cover for the TV remote is always the first thing to break and the hardest to replace. It's the custom-molded foot on your coffee maker that gets lost during a move, leaving it to wobble forever. It's the knob on your washing machine that cracks, forcing you to turn the stem with a pair of pliers for the next 5 years. We are surrounded by tiny, deliberate points of failure, designed to turn functional, expensive products into landfill. Until now, with a 3D printer, you become the manufacturer. You become the parts department. That 3-cent dishwasher clip? Someone somewhere in the world has had that exact same problem. They got frustrated, they pulled out their digital calipers, they measured the broken piece, and they designed a perfect one-to-one replacement. And then, in the incredible open-source spirit of the 3D printing community, they uploaded that file for free to a website like Thingiverse or Printables. So now your process is different. The clip breaks. You sigh, but you don't despair. You grab your phone, you type dishwasher model number rack clip into a search bar, and you find the file. You download it, you send it to your printer, and in 20 minutes, for about 8 cents worth of durable heat-resistant PTG plastic, you have a brand new clip. It might even be stronger than the original. You snap it into place. The dishwasher is whole again. You didn't just fix an appliance. You took a stand. You defied a system designed to take your money and create waste. You looked at a corporation and quietly said, "No, not today." This is empowerment on a level we've never had before in our own homes. Let's take it a step further. It's not just about what breaks. It's about what was lost. Think about family heirlooms. There's a story of a man who inherited his grandmother's beautiful 60-year-old stand mixer. A classic, built like a tank, all metal and chrome. He used it every week to make bread just like she did. But one day, a small internal nylon gear, a part that hadn't been manufactured in decades, finally stripped its teeth. The motor would whine, but the paddle wouldn't turn. The mixer, full of memories and meaning, was dead. A beautiful $200 paperweight. He called repair shops. They laughed. He looked online. Nothing. But he found a community of vintage appliance restorers. And in that forum, someone had painstakingly created a 3D model of that exact obsolete gear. He downloaded it. He didn't have a printer himself, so he used a local library's machine. He printed the gear out of nylon just like the original. He spent an afternoon taking the mixer apart, replaced the tiny, broken piece with his freshly printed one, and reassembled it. He plugged it in, held his breath, and turned the dial. The mixer whirred to life, the paddle spinning as powerfully as it did in his grandmother's kitchen 60 years ago. He didn't just fix a machine. He resurrected a memory. He preserved a piece of his family's history. That is a power that money cannot buy. And it was enabled by a digital file and a machine that builds things layer by layer. This power to repair and restore is just the beginning. The real magic starts when you move beyond fixing what's broken and start improving what isn't. You start creating things that never existed in the first place. Solutions perfectly tailored to you and your home. Look at your kitchen junk drawer. We all have one. It's a chaotic mess of batteries, rubber bands, pens, and miscellaneous hardware. You can buy pre-made drawer organizers, but they never quite fit. There are always awkward gaps, wasted space. With a 3D printer, you can design and print a custom grid that fits your drawer's exact dimensions, with perfectly sized compartments for the specific things you store in it. A slot for AA batteries, a little tray for paper clips, a holder for your tape measure. Suddenly, chaos becomes order. You didn't just organize a drawer. You redesigned a small part of your world to work perfectly for you. This extends everywhere. You can print a bracket that hangs your ridiculously oversized gaming headset perfectly under your desk. You can print a custom mount for your smart speaker that angles it directly at your favorite chair. You can design and print a coffee pod dispenser that fits in that weird, narrow space next to your coffee machine. You can create custom-fit inserts for your toolbox, so every wrench and screwdriver has its own designated spot, a practice known as shadowing, used by professional mechanics. You can print child safety latches for that one cabinet that's a weird shape and no commercial lock will fit. You can print a replacement battery cover for that 15-year-old remote control, a piece of plastic that would have been impossible to find any other way. You stop being a passive consumer, forced to accept the one-size-fits-all solutions offered by big box stores. You start seeing your environment not as a fixed reality, but as a canvas. The gap between, I wish I had something that did this, and I have something that does this shrinks from months of searching and hundreds of dollars to a few hours of designing and a few cents of plastic. Your home starts to conform to you, not the other way around. Every custom-printed object makes your life a little easier, a little more efficient, a little more personal. This is a fundamental shift in our relationship with the objects around us. We're moving from a culture of disposable consumption to a culture of permanent ownership, repair, and customization. Every time you print a replacement part, you're keeping an object out of a landfill. Every time you create a custom solution, you're refusing to buy a mass-produced item that doesn't quite work. You're not just a homeowner anymore. You are an inventor, an engineer, a restorer, living in a home that you can constantly refine and improve on a microscopic level. We've taken this power from restoring the human body to restoring our homes. We've brought this incredible capability right into our most personal spaces. But what happens when we turn this lens outward? What if we could use it not just to create small objects but to create flavor? To create things we can actually taste and eat? That's right. I'm talking about 3D printed food. And no, this isn't some far-off science fiction concept from a Star Trek replicator. This is happening right now in kitchens and labs around the world, and the technology is becoming more accessible every single day. The idea of a machine printing your dinner might sound strange, even a little unsettling at first. We associate food with nature, with farms, with the human touch of a chef or a loving parent. So, the question is, why would we ever want to hand that process over to a machine? The answer, it turns out, is as complex and layered as the food it can create. First, let's get one thing straight. A food 3D printer isn't creating matter out of thin air. It's more like an incredibly precise, automated pastry chef. Instead of extruding melted plastic, it extrudes edible ingredients from food-safe cartridges, things like chocolate, dough, cheese, or even vegetable purees. It builds your food layer by delicate layer, following a digital blueprint with a level of precision that is simply impossible for human hands. And that precision is the first reason this is so revolutionary, unparalleled creativity. Imagine a wedding cake decorated with a sugar lattice so intricate it looks like spun glass. Picture serving your kids pancakes in the exact shape of their favorite cartoon characters, perfectly rendered every single time. Or think about pasta. We're used to maybe a dozen different shapes. A 3D food printer can create thousands of new, complex geometries, each designed to hold sauce in a unique and perfect way. Companies are already using this to create breathtaking chocolate sculptures and custom-branded snacks for events. It transforms food from just sustenance into a new medium for art and expression. But the real world-changing potential goes far beyond fancy shapes. It's about personalized nutrition. This is where it gets truly mind-blowing. Think about your own health goals. Maybe you're an athlete training for a marathon, needing a very specific ratio of protein, carbs, and fats. Maybe you're managing a health condition like diabetes and need to control your sugar intake with absolute precision. Or consider the elderly, especially those in nursing homes who may have difficulty chewing and swallowing, often being stuck with unappetizing pureed meals. Now, imagine a device in your kitchen that syncs with your fitness tracker or your medical records. It knows you just finished a hard workout. It knows your vitamin D levels are a little low, and it automatically prints a meal for you. Let's say a piece of salmon-shaped vegetable protein, with the exact number of calories, the precise amount of protein for muscle recovery, and an extra boost of the specific vitamins you need. For the elderly patient, it could print that same pureed food, but in its original appealing shape, making a carrot look like a carrot again, restoring dignity and enjoyment to mealtime. This isn't just a novelty. It's a tool for targeted, preventative healthcare delivered right on your plate. And the story gets even bigger. Let's talk about sustainability. Food waste is a colossal global problem. We throw away billions of tons of perfectly edible food every year. At the same time, our traditional sources of protein, like cattle, have a massive environmental footprint. Food 3D printing offers fascinating potential solutions. Researchers are experimenting with using ingredients that are typically overlooked or discarded, like ugly fruits, vegetable scraps, or even alternative protein sources like algae or insect powder, and transforming them into nutrient-dense, visually appealing food pastes. It's a way to create value from waste, to make sustainable proteins more palatable to the mainstream consumer. Imagine a future where your food scraps from yesterday become the custom-printed crackers you eat today. Of course, the big question on everyone's mind is, what does it taste like? And is it safe? It's a fair question. And the answer is simple. It tastes like whatever you put into it. The printer is just an assembly tool. If you fill the cartridges with high-quality, delicious ingredients, you'll get a high-quality, delicious result. If you use bland, low-quality paste, well, you'll get a very precisely shaped but still bland meal. The core principle of cooking remains. Garbage in, garbage out. The machinery itself is designed with food-grade stainless steel components that are easy to sterilize. No different from the other appliances and tools already in our kitchens. The pioneers in this space are already pushing the boundaries of what we thought was possible. NASA has been funding research for years to develop a food printer for astronauts on long-duration missions, like a trip to Mars. The goal is to provide varied and nutritious meals to maintain crew morale and health, printed from powders with a long shelf life. Here on Earth, innovative companies are 3D printing plant-based steaks, complete with complex muscle fibers and fat marbling, creating a texture and mouthfeel that is remarkably close to the real thing. They're not just printing a veggie burger, they're printing an experience. This is the dawn of digital gastronomy. It's a convergence of software, hardware, and culinary arts. It's the ability to share a recipe not as a list of instructions, but as a digital file that can be perfectly replicated by anyone, anywhere in the world with the right machine. It's a future where your diet is no longer a generic set of guidelines, but a hyper-personalized, dynamically adjusting stream of nutrition designed for your unique body. It's a world where art, health, and sustainability can all be served on the same plate. We started this journey by shrinking massive industrial machines into a box that could sit on our desk. We used it to print trinkets, tools, and replacement parts. We brought this incredible capability right into our most personal spaces, and now we're using it to create the very fuel that powers our bodies. We've gone from printing solid plastic objects to printing edible, nutritious food. We've mastered the inanimate and even the delicious. But the ultimate frontier for creation has always been life itself. What if we could use these same principles of building layer by layer not just to feed a body but to help build one? To print something that could literally save a life? The answer, astonishingly, is yes. We can. And it's not happening in some far future laboratory. It's happening right now, in basements, in garages, in makerspaces, powered by the very same desktop printers we've been talking about. Let's talk about prosthetics. For decades, getting a prosthetic hand or arm has been a monumental undertaking. It's a world of specialists, of expensive fittings, of devices that can cost tens of thousands of dollars. Now imagine you're a parent of a child born without fingers on one hand. You want to give them every advantage, every tool to navigate the world. But the cost is staggering. And even if you could afford it, there's a bigger problem: kids grow. A prosthetic that fits today will be too small in a year or even 6 months. You're trapped in an endless, financially draining cycle. It's a heartbreaking reality for thousands of families. This is where a prop maker from Washington and a carpenter from South Africa, two men separated by 10,000 miles, connected over the internet and changed everything. The prop maker, Ivan Owen, had created a giant mechanical puppet hand for a costume. Someone who saw it online reached out with a question. Could this same principle be used to make a functional hand for a child? That question sparked a revolution. They collaborated, sharing designs and ideas back and forth, and eventually created the first 3D printed prosthetic hand. They didn't patent it. They didn't try to sell it. They gave it away. They uploaded the design files to the internet for free, for anyone to download, modify, and print. And with that single act of generosity, an organization called Enable was born. It's not a company. It's a global movement. A network of thousands of volunteers, engineers, teachers, students, hobbyists, who use their own home 3D printers to create and assemble custom-fit prosthetic hands for children in need, completely free of charge. Suddenly, the entire paradigm shifted. The $10,000 problem now had a $20 solution. A child who used to wait months for a fitting can now have a new hand printed in a day. And the best part? The kids are involved in the design. They don't get a cold, clinical-looking device. They get to choose their own colors. They can ask for a hand that looks like Iron Man's, or has the logo of their favorite superhero, or glows in the dark. These aren't just medical devices anymore. They are expressions of personality. They turn a disability into a superpower. A 3D printer sitting on a desk takes a spool of plastic and transforms it into a child's confidence, into their ability to hold a baseball bat for the first time, to ride a bike, to simply hold their parent's hand. It's not just printing an object, it's printing a new possibility for someone's life. This idea, this principle of creating a perfectly tailored, one-of-a-kind solution for a specific individual, is now exploding across the entire medical field. And it's saving lives in ways that are even more direct and profound. Consider the terrifying world of complex surgery. Imagine a team of surgeons about to perform a life-or-death operation on a newborn baby's heart. A heart no bigger than a strawberry, with defects that are unique and incredibly intricate. In the past, surgeons would rely on 2D images from CT scans and MRIs. They would have to build a 3D model in their minds, trying to visualize the complex web of arteries and chambers before ever making the first cut. The pressure is immense. There is zero room for error. Now picture this. The day before the surgery, the lead surgeon holds an exact 1:1 scale replica of that tiny heart in her hands. It's printed in a clear resin, with the different chambers and vessels color-coded for clarity. It was created directly from the baby's own MRI data, a perfect physical copy of the unique challenge they are about to face. The surgical team can gather around it. They can turn it over, look at it from every angle, and see precisely where the problem is. They can physically trace the path their instruments will take. They can practice the procedure, identifying potential complications and planning their approach with a level of precision that was previously unimaginable. They are essentially performing the surgery before the surgery. When they finally walk into the operating room, they aren't going in with just a mental map, they are going in with muscle memory. This isn't science fiction. Hospitals and medical centers all over the world are doing this right now. They are 3D printing patient-specific anatomical models for brain tumors, for complex facial reconstructions, for kidney transplants. It's reducing time under anesthesia, minimizing risks, and leading to better outcomes. That 3D printer in the hospital's lab isn't just making a plastic model. It's buying a surgeon precious time and giving a patient a better chance at life. And we can take it one step further. What if we move beyond printing models to practice on, and start printing the actual parts that go inside the human body? We're now entering the world of custom medical implants. The human body isn't made of standardized parts. Your hip socket is unique to you. The curve of your spine is unique to you. For years, orthopedic implants have been mass-produced in a range of standard sizes: small, medium, large. A surgeon would have to find the one that was the best fit, and sometimes even modify the patient's own bone to make it work. But with 3D printing, specifically a technique called direct metal laser sintering, we can flip that script entirely. We can now print implants from medical-grade materials like titanium, custom designed from a patient's own scans to fit their anatomy with microscopic precision. A patient who lost a large part of their jawbone in a car accident can receive a new 3D printed titanium jaw that is a perfect mirror image of the one they lost. Someone with a degenerative spinal condition can receive a custom-printed vertebral cage that fits the unique curvature of their spine, promoting better fusion and a faster recovery. These aren't just replacements, they're upgrades. Because we can control the internal structure of the print, we can design these implants with complex, lattice-like surfaces that mimic the texture of real bone. This encourages the patient's own bone cells to grow into and fuse with the implant, making it a permanent, integrated part of their own skeleton. From plastic hands that give a child a new sense of self, to practice models that guide a surgeon's scalpel, to titanium bones that rebuild a human body from the inside out, 3D printing has become an indispensable tool in modern medicine. We are building better, more personalized solutions layer by layer. We've printed non-living materials to support life. But what if we could take the ultimate leap? What if we could use a printer not just to create the scaffold, but to print with the living bricks of life itself? The answer is no longer science fiction. It's called bioprinting, and it represents a paradigm shift so profound, it forces us to redefine the very boundary between manufacturing and life itself. Forget printing with plastic, resin, or metal. Bioprinting uses an ink made of living human cells. Think about that for a second. The nozzle of the printer isn't extruding a molten polymer. It's carefully, precisely depositing living cells suspended in a nutrient-rich gel called a hydrogel. Layer by microscopic layer, it's not building an object, it's assembling a living tissue. The blueprint isn't a CAD file for a wrench or a figurine. It's a detailed 3D map of a human organ, often derived from a patient's own MRI or CT scan. The ultimate goal here isn't just to create a replacement part for a machine, but to create a replacement part for a human being. The process is as delicate as it is revolutionary. It begins with that digital blueprint. Scientists then cultivate the necessary cells. These could be stem cells, which have the remarkable ability to differentiate into various cell types, or they could be specific cells like liver cells or skin cells, taken from the patient themselves. These cells are then mixed into the bioink, the hydrogel that acts as both a temporary scaffold and a life support system, providing a structure for the cells to cling to and grow within. Then the printing begins. The bioprinter, operating in a completely sterile environment, extrudes the bioink with pinpoint accuracy. It might lay down a layer of cardiac muscle cells, then a layer of cells that will form blood vessels, then another layer of connective tissue, meticulously following the biological architecture of the real thing. But here's the most critical part, the step that truly separates this from any other form of printing. The printed object is not the final product. It's just the beginning. What comes off the print bed is a pre-tissue, a precisely organized collection of cells that needs to mature. It's placed inside a bioreactor, a sophisticated incubator that's engineered to mimic the conditions inside the human body. It provides a constant flow of nutrients, oxygen, and gentle physical stimulation, like the rhythmic pressure of blood flow, to coax the individual cells into communicating, connecting, and self-organizing into a complex, functional living tissue. It's in this crucial maturation phase that the magic truly happens, where a printed construct begins to behave less like a collection of cells and more like a part of a living organism. So why are we doing this? Why are the brightest minds in medicine and engineering pouring billions of dollars into this field? The first and most immediate answer is to revolutionize how we develop new medicines. For decades, drug testing has followed a predictable path. Test on cells in a petri dish, then on animals, then finally on humans. This process is slow, incredibly expensive, and tragically, often fails because animal biology doesn't perfectly replicate human biology. Bioprinting changes the game completely. Instead of testing a new liver drug on a mouse, pharmaceutical companies can now print thousands of identical miniature human livers. We're talking about tissues the size of a pinhead that are biologically active. They can then test hundreds of drug variations on this real human tissue, getting incredibly accurate data on both effectiveness and toxicity in a fraction of the time and cost, all without ever endangering a human patient or an animal. We are already seeing this today. Scientists are printing beating heart tissues on a chip to test cardiac drugs and lung tissue to study the effects of new asthma medications. It's a faster, safer, and more ethical path to discovering life-saving cures. The next step is personalized medicine at a level we've only ever dreamed of. Imagine a cancer patient. Instead of subjecting them to a brutal one-size-fits-all chemotherapy regimen, doctors could take a small biopsy of their tumor, use those cells to print dozens of tiny, identical copies of that patient's specific cancer, and then test a whole spectrum of different cancer-fighting drugs on those printed tumors in the lab. They could identify the single most effective treatment for that individual's unique disease before a single drop of chemotherapy enters their body. This isn't a far-off fantasy. It's the very near future of oncology. But of course, the ultimate vision, the holy grail of bioprinting, is the creation of full-scale, transplantable human organs. Right now, in the United States alone, over 100,000 people are on the national transplant waiting list. Every single day, people die waiting for a compatible heart, liver, or kidney that will never come. Bioprinting offers a potential future where this waiting list simply doesn't exist. The vision is this. A patient with kidney failure has some of their own healthy cells taken. Those cells are multiplied in a lab and used to create a patient-specific bioink. A printer then uses their medical scans as a blueprint to print a brand new, perfectly healthy kidney, built from their own genetic material. Because the organ is made from their own cells, the body's immune system would recognize it as self. The risk of organ rejection, the single biggest danger in transplants today, could be completely eliminated. Patients wouldn't need a lifetime of powerful immune-suppressing drugs. The organ would be a perfect, seamless biological match. Now we must be clear. We are not there yet. Printing a complex, solid organ like a kidney, with its billions of cells, intricate filtering systems, and vast network of blood vessels, is one of the most complex engineering challenges humanity has ever faced. The single biggest hurdle is vascularization, creating the arteries, veins, and tiny capillaries that can deliver oxygen and nutrients deep into the core of the organ to keep the cells alive. Without it, you can only print very thin tissues because any cells more than a fraction of a millimeter from a nutrient source will die. But the progress is breathtaking. Researchers at the Wake Forest Institute for Regenerative Medicine have already successfully printed and implanted bone, muscle, and cartilage structures in animals that have matured and integrated with the host's body. Scientists have printed functional skin grafts directly onto the wounds of burn victims. They've printed corneas that could one day cure certain types of blindness. And incredible breakthroughs are happening in printing those vital vascular networks, the highways that will eventually allow us to build bigger and more complex tissues. We are standing at the dawn of a new medical age. The same fundamental technology that lets a hobbyist print a plastic toy is being harnessed to assemble the very fabric of life. We've journeyed from printing simple objects, to complex tools, to entire buildings. We've scaled our ambition to print life-saving implants that perfectly match an individual's anatomy. And now we are on the cusp of printing with life itself, creating living, breathing tissues that could one day mend our bodies from the inside out. We have mastered printing the inanimate. We are now learning to print the animate. We've scaled down to the level of the cell. But there's one frontier left. What happens when this technology matures to the point where it doesn't just replicate things that already exist, but starts creating things that are fundamentally new? What happens when a 3D printer can build not just static objects or living tissue, but other machines? Machines that can operate, build, and perhaps even improve themselves? The answer is, you get a technological singularity in your own workshop. You get the final and most profound item on our list. The number one most mind-blowing thing you can create with a 3D printer is another 3D printer. This isn't a riddle. It's the realization of a dream that's been quietly growing in the open-source community for over a decade. A project known as RepRap, which stands for Replicating Rapid Prototyper. The core idea is as simple as it is revolutionary: to create a 3D printer that can print the majority of its own parts. It's a machine that can reproduce. Think about the power of that for a moment. This isn't just another object you can download and print. It's the machine that makes the objects. It's not just getting a fish, it's getting a fishing rod that can build more fishing rods. This concept breaks the traditional rules of manufacturing and economics. A normal machine like a car or a laptop depreciates. The moment you buy it, it starts losing value. A RepRap printer is different. It's a machine that appreciates in value, not in a monetary sense but in a functional one. Its value is its ability to create another version of itself for a friend, for a school, for a community center, for the cost of the raw materials. The project was started in 2005 by Dr. Adrian Bowyer at the University of Bath in England. His vision was not just to create a low-cost 3D printer, but to create a machine that could spread virally like a biological organism. He wanted to place the power of manufacturing into the hands of everyone, to fully democratize the means of production. And the incredible thing is, it worked. Nearly every single consumer-grade 3D printer you can buy today, from Creality to Prusa, owes its lineage directly to the open-source DNA of the RepRap project. So how does it actually work? A 3D printer can't print everything, of course. It can't print the microchips, the stepper motors, or the smooth metal rods that the print head glides on. These components are called vitamins, the parts the printer can't make for itself and has to source from outside. But here's the magic. It can print almost everything else. The frame that holds it together, the intricate gears that move the filament, the brackets, the mounts, the extruder body. All of these complex plastic parts can be printed by a parent machine for its child. A complete set of these printed parts might take 100 hours or so to print and use about 2 pounds of plastic filament, costing maybe $40. You then combine these printed parts with a few $100s worth of vitamins, and you have a brand new, fully functional 3D printer. A machine that cost you, say, $500 to buy, can create a sibling for about half that price. And that sibling can then go on to create another, and another, and another. The process is exponential. This isn't just a cost-saving measure. It's a catalyst for explosive innovation. Because the designs are open source, anyone, anywhere in the world, can download them, modify them, and improve them. And they do. A tinkerer in Ohio might design a better fan duct for cooling prints. They upload their design to a site like Thingiverse or Printables. Within hours, a student in Japan can download that part, print it, and install it on their own machine, instantly upgrading it. Then, a retired engineer in Germany might take that design and improve it even further. This creates a global, collaborative, and lightning-fast evolutionary cycle. The printers are constantly getting better, not because of a single company's R&D budget, but because of the collective brainpower of millions of users. They are a technology that is actively being improved by the very people who use it. If a part on your printer breaks, you don't have to call customer service and wait for a replacement to be shipped from across the world. You just go online, download the file for that part, and print a new one. The machine is self-repairing. The implications of this extend far beyond a hobbyist's garage. Imagine the potential in education. A single printer donated to a school library can become a fleet of printers for every classroom, built by the students themselves. They learn design, engineering, and manufacturing not from a textbook, but by literally building the technology from the ground up. Think about the developing world. Instead of shipping crates of finished goods, you could ship a single 3D printer. That one machine, a technological seed, could then be used to print water pump components, basic medical supplies, tools, and yes, more printers for neighboring villages. It's a way to bootstrap a technological ecosystem, to build a local manufacturing base from virtually nothing. It bypasses global supply chains and empowers communities to solve their own problems with their own resources. This is the ultimate expression of what a 3D printer represents. It's the culmination of this entire list. We started with simple household items, clever gadgets that make life a little easier. We moved on to custom-fit solutions, from ergonomic tools to life-changing prosthetic limbs that give people back their mobility. We explored the frontiers of science, printing custom lab equipment, and even living human tissue, rewriting the rules of medicine. But all of those incredible creations rely on the existence of the printer itself. The ability to print a printer is different. It's a meta-level creation. It ensures that the power to do all those other things can spread to anyone, anywhere, without permission from a corporation or a government. It transforms the user from a mere consumer into a creator and a distributor. We are living in the first few moments of a new industrial revolution. For all of human history, the ability to manufacture complex goods was concentrated. It was in the hands of guilds, then factories, then multinational corporations. It required immense capital and infrastructure. The RepRap project and the thousands of printers it inspired shatters that model. It says that a factory doesn't have to be a giant building full of million-dollar machines. A factory can be a small, quiet device sitting on your desk. This isn't a future prediction. It is happening right now. The printer you might buy tomorrow could very well have parts on it that were designed by a teenager on a different continent just a few weeks ago, printed and assembled in a small workshop, based on a design that is freely available to all of humanity. So when you look at a 3D printer, don't just see a machine that makes plastic trinkets. See it for what it truly is, a foothold in the future. A future where the barrier between imagination and reality is thinner than it has ever been. It's a machine that doesn't just build objects, it builds possibilities. It builds freedom. The freedom to fix, to improve, to create, and to share. We've journeyed through 10 incredible things you can create, from the practical to the fantastical. But the real mind-blowing thing isn't any single object on this list. It's the underlying shift that this technology represents. The power to turn digital bits into physical atoms is now in our hands. The question is no longer what can we create. The question is, what will you choose to create?